All right, so welcome to today's lesson. For those who do not know me, my name is Tutor Paul Solutions. Okay, I'm a tutor at DISCRETE Learning Institute. So we provide extra lessons, online extra lessons, okay, for math, chemistry, physics, and biology. Okay, so you can learn anytime, anywhere, at your own pace. Okay, so today's video, we are going to focus on this assignment one for Levy. Okay, so this is chemistry. So if I explain anything and you do not understand, please don't hesitate to ask. Okay, ask. That's the reason you joined this class. So be free with me. I'm very interactive. Okay, you can ask me any questions as we'll be solving this assignment. Okay, so I hope you enjoy this and you learn one or two things that you didn't know. Right, so we're going to solve all these questions that you can see here. We're going to solve them one by one. So there are how many questions here? 10 questions. Okay, so we are going to solve all of them one by one. Right, so let's go to the questions here. So the first question here, they're saying, okay, so the first question there, we're just defining some definitions. Okay, so the first question they're saying, distinguish between a measured number and an exact number, and then give two examples of each. Okay, so let's start with a measured number. Okay, so anyone who has an idea of what a measured number is, what is a measured number? Anyone who has an idea? What's a measured number? All right, so a measured number is a number, or you can say it's a value, okay, obtained, a value obtained from a measuring instrument. Okay, a value obtained from a measuring instrument. Okay, and this instrument should have some degree of uncertainty. Okay, so a measuring instrument that has some degree of uncertainty. Okay, so a measured value is just a value obtained from a measuring instrument that has some value of it has some degree of uncertainty. Okay, so uncertainty simply meaning it does not measure the exact value of that thing that you are measuring. Okay, there will be some degree of uncertainty there. There will be some error there. So maybe if you have maybe an apple, okay, that weighs 10 kgs. Okay, you have an apple that weighs 10 kgs, and then you put that apple on the scale. It's not going to read exactly 10 kgs or 10 grams, I mean. It's not going to read exactly 10 grams. It's going to read maybe 99.99 grams. Okay. So that error that makes us not get this the exact value, okay, or the exact weight of that apple is what we are referring to as some degree of what? Uncertainty. So a measured value is a value that you obtain from a measuring instrument. Okay. So for example, you can measure the length of your book with a ruler. Okay. The number that you're going to get there, or a value that you're going to get there, we call that as a measured what? Number. Okay. You can also measure the mass, like I gave an example of an apple. Okay. That number that you get from there, it will be called a what? A measured number. Okay, so those are some of the examples that you can give. All right, so maybe I should write them down there. You can say a mass of 99.99 grams, okay, measured on a scale. Okay, and then the second example, you can say a length, okay, a length of 12.7 centimeters. Okay, so that's what you can say there. All right. Okay, so that is the definition of a measured value, a measured number, I mean, and then even some examples there. So now I'm going to go to what we call as exact numbers. Okay, so what are exact numbers? Anyone who has an idea what exact numbers are? What are exact numbers? Okay, so an exact number is a value, okay, that is obtained by counting. So a value that is obtained by counting is what we call as an exact value. Or you can say it is a value, okay, from standard definitions. Standard definitions. Okay, so a number that you get by counting, or a number that you obtain from standard definitions, okay, is what we call as an exact number. And this exact number has no uncertainty in it. Okay, so if, for example, you count, maybe you have pens in your hands, and then you count 1, 2, 3, you have 4 pens. Okay, so this number here, 4 pens, it will be exactly the amount of pens that you have in your in your hands. So there will be no uncertainty in that case. So we call that as an exact number, a number obtained by counting. Or if I come in your class and then I count how many you are, okay, so that number that I'll obtain is an exact what? An exact number. Okay, and then another example can be the example that comes from this second part where we're saying a value obtained from what? Standard definitions. Okay, so I was supposed to write definitions there. So a value that is obtained from standard deviations. Okay, so for example, we know that 12 inches, okay, 12 inches make up 1 foot. Okay, so this 12 inches making up this 1 foot here is an exact number, okay, because it's obtained from a definition. Or when we say 1 dozen, is it dozen or 1 dozen? I don't know your pronunciation, okay, but I get you. I hope you get what I mean. So if you say 1 dozen, okay, you just mean 12 items. Okay, they can be 12 books, they can be 12 pens, they can be anything. But we know that 1 dozen is just what? 12 items. So these numbers that are from definitions like that, they are also called exact numbers. Okay, so that is it there on question 1. We've defined a measured value. We gave examples. We've defined an exact number. We also gave examples there. Right. So I'm sure there are no questions here. If there are any questions, you're free to ask. All right. Now let's look at question 2. Question 2, they're saying define accuracy, okay, and precision in the context of scientific measurements. Okay, so these are very important concepts that you need to learn when you are doing chemistry, especially for you guys who are going in the medical field. Okay, you will be using this accuracy and precision almost everywhere. So someone is writing on my screen. I don't know. Let me cancel annotations here for this. Okay, annotate, and then okay, let me erase this part. Let me cancel annotations for you guys. Disable annotations. Okay, that's better. All right, so I was saying you're going to come across these 2 concepts, okay, whenever you go into your field, which is health, right? Okay, so you have to be accurate when you're giving maybe medicines to someone, okay? There's the issue of precision, okay, all that you're going to be experiencing them like in a practical way. So what is this accuracy and what is this precision? Okay, so accuracy is defined as, okay, how close a measured value, okay, how close a measured value is to the true value. Okay, so this is the definition of what accuracy. It's just how close a measured value is to the true value or the accepted value. So for example, if the true value of a certain object, maybe it's 5 kgs, okay, and then you get this same object, you put it on your scale, Okay, you put it on your scale there, and then maybe it weighs 4.999 because of some errors. Okay, we are going to say this measurement here is accurate. Why? Because it's so close to the what? To the true value there. That's what we mean by how close a measured value is to the what? The true value. All right, and then what is precision there? So precision is how close, okay? How close multiple measurements or a lot of measurements, okay? How close multiple measurements, okay, are to each other. Okay, so they may not be necessarily close to the true value, but they should be close to one another. Then we are going to say that those measurements are what? Precise. Okay, so if this is our true value, and then maybe I measure this same object on a scale, and then I obtain maybe 3.2, and then another one 3.1, 3.0. Okay, so these three measurements that I've written down here, they are close to each other, but they are not close to the true value. Okay, so by the fact that they are close to each other, we say they are what? Precise. Okay, so precision, how close the measurements are to each other, even though they are not close to the true value. But for the accuracy, the measured value has to be close to the what? Uh, to the true value or the accepted value. Okay, so that's the difference between those two. And then in some cases, I've seen students usually get confused. Okay, so in some cases, they will give you multiple measurements like this, and then they'll ask you, are these measurements accurate or are they precise? Okay, so you don't judge, if you are given multiple measurements, you don't judge the accuracy based on one measurements like that. No. Okay. So what do you do in order to judge the accuracy if you are given multiple measurements like that? Okay. You add or you find the average of the measurements that you've been given. So here we can add this one to this one to this one, and then you divide by how many they are. So if I add 1, 2, 3, I'm going to divide by 3. And then now you compare the average that you get, you compare it to the true value. So if the average is far away from the true value, you are going to say they are not accurate. Okay. If the average that you get is closer to the true value, you're going to say it's what? Accurate. Okay. So make sure when you're given multiple measurements and then they're asking you about the accuracy, don't compare one entry to the true value. No. First of all, find the average and then compare that average to the true value. Okay. And then for the precision there, you just take a look at those measurements. If they are close to one another, we say they are precise. If they are not, we say they are not precise. Okay, so that's the definition of accuracy and precision there. All right, so in my written solutions, I think I've added some examples there. So I'll be able to share them after this class. Okay, let's look at question 3. So question 3 now, they're saying for each of the following quantities, underline the zeros that are significant and determine the number of significant figures in each quantity. So before we can even answer any question here, we have to be highlighted, okay, of the rules, okay, when it comes to significant figures, okay. So the first rule when it comes to significant is that all non-zero digit numbers, okay, are what? Significant. So as long as a digit is not zero, it is considered as significant. So for example, 7, 5, 3, 4, 1. Okay, as long as that number is not zero, it is what? Significant. And then the other rules, they center around the zero. Okay, so we have about 3 types of zeros. We have the trading zeros, we have the captive zeros, we also have the leading zeros. Okay, so depending on the type of zero that you have, okay, there are some certain rules that you have to follow. So I'll start by the leading zeros. Leading zeros, okay? So these leading zeros are never significant. Okay, never significant. So when you just see a leading zero, just know that it's not significant. So leading zeros, we mean the zeros that appear before a non-zero digit number. So for example, if I write 0.0004, these zeros here that are appearing before this non-zero digit number are what we are referring to as what? The leading zeros. So those leading zeros, they are never significant in any number. Okay? And then the other rule is that captive zeros, okay, captive zeros are always significant. Okay, so the captive zeros, by captive zeros, we mean zeros that are between non-zero digits. Okay, so for example, if I write 3009, so these two zeros here are between these 3 and 9, which are non-zero digits. Okay, so whenever you have captive zeros, you consider those zeros as what? Significant. So they are always significant. As long as they are captive zeros, they are always significant. And then the other rule is um, on the trading zeros. Okay, so the trading zeros have a condition to them. Trading zeros. So these ones can be significant and they can also be not significant depending on the number that you have. Okay, so these trading zeros are only significant if the number, okay, if the number contains a decimal place or a decimal point. Okay, so if there's a decimal point in that number, and then you have trading zeros, just know that those trading zeros are significant. So what are trading zeros? The trading zeros are zeros that come after the non-zero digit numbers. So for example, I can write 33200. Okay, so these zeros here, they can only be significant if in this number there is a decimal place like that. Okay, and then we can say that these here are significant. If I write it like 33200 without a decimal point there, then these won't be significant. But if there's a decimal place like that, it means they are what? Significant. So take note of that. Okay, so these are the rules that you need to know when you talk about significant figures. So now that we've understood these rules, we can actually answer these questions here. Maybe I should just leave the rules there, okay, so that we can be referring them. We can be referring to them. Okay, so let's start with the first one. So A, they're saying 0.000450 liters. Okay, so the first condition here is they're saying underline the zeros that are significant. So these zeros here, the leading zeros, these ones here, they are not significant. Why? Because they are leading zeros. We said leading zeros are never significant. Okay, so the only zero that is significant is this one. So this one here is a trading zero, and it's coming what? In a number that has a decimal point there. So it means this zero there is significant. Okay, so we have underlined the zero that is significant. Okay, and then now let's count how many significant figures we're going to have. We're just going to have 1, 2, 3. So it means there we just have what? 3 significant figures. Okay, let's look at B. So if you have any questions, guys, be free to ask. So 1.5005 grams. So let's underline the significant zeros. So the significant zero will be these two here. Why? Because they are what? Captive zeros. They are between two non-zero digits. Okay, so how many significant figures are we going to have here? 1, 2, 3, 4, 5. We're going to have 5 significant figures. Okay, C, we have this number 67000000. Okay, so is there any significant zero here? No. Why? Because all these zeros here are trading and there is no decimal point. So we are going to consider all these zeros as non-significant. So it means the number of significant figures in this number will just be what? 2 significant figures. Okay, D, we have 67000000 and a decimal point there. Okay, so this decimal point here makes all these zeros there, should use blue, makes all these zeros here to be what? Significant. So it means this number will contain how many significant figures? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 significant figures. So you always have to follow the rules. And then let's look at the last one, which is E, the same 4508 milliliters. So there, the zero is a captive zero. So this one here, we're going to underline like that. So that zero is significant. So it means how many significant figures do we have in this number? 1, 2, 3, 4. So I'm just going to say 4 significant figures. All right. So any questions there, guys? Any questions? Okay, no questions. So make sure these assignments you are getting everything, okay? Because you can solve with your friends and we can also help you. So make sure in the assignments you always get everything, okay? So that your CA should be a good CA, so that you don't have to suffer when it's time for the exam. Let's look at question 4. Okay, so question 4, we are rounding off to the indicated significant figures. Okay, so the first one there is 0.006554. So they want us to round off this number to 2 significant figures there. Okay, so 2 significant figures, it means my rounding off is going to happen here. Okay, it's going to happen there. So I'm going to ask myself, is this number here greater than or equal to 5? If it's greater than or equal to 5, I'll add 1 to the next number. Okay, if it's not, I'll just leave this number the way it is. So if we round off this number here to 2 significant figures, it's just going to be 0.0066, because this 5 here is equal to 5. So we add a 1 to this guy. So it's going to become this. If you want, you can also represent your number in scientific notation. Just make sure that it has 2 significant figures. So this can also be represented as, so I'm going to move this decimal place 1, 2, 3. Okay, so it will be 6.6 times 10 to the power. How many times have I moved? 1, 2, 3. So I've moved 3 times to the left. I mean to the right. So if you move to the right, it means your power here on the 10 should be a negative. So that would be -3 like that. So this number here has 2 significant figures. Even the one on top there has 2 significant figures. So you choose your best, okay? All right, so B, if there are no questions there, I'll go to B. So 64.73 and then 48. They're saying we express this number to 4 significant figures. Okay, so 4 significant figures, I'm going to come here. Okay, I'm going to ask myself, is this number greater than or equal to 5, or is it less than 5? So we see that 4 is less than 5. So we're not going to add anything to this. So when we round off this, it's just going to be 64.73. So this number here has 4 significant figures. If you want, you can represent it in scientific notation. You're going to move this point 1 place to the left like that. So it will be 6.473 times 10 to the power 1. Since I'm moving to the left, my power there should be what? Positive. So it's the opposite. If you move to the right, your power is negative. If you move to the left, your power should be what? Positive like that. Okay. So one thing I should mention on the on representing it in scientific notation like this is that the number that you have there or there should always be less than 10 but greater than 1. Okay, that's what scientific notation is. The number that should be there should be less than 10 but greater than 1. So meaning if you have the number 55.23 whatever times 10 to the power 6, this here is not scientific notation. Why? Because this number here is not less than 10. Okay, or if you have a number 0.002 times 10 to the power -3, this here is not scientific notation. Why? Because this number here is less than 1. So the number that should be there should always be 1 greater than 1 and then 2 less than 10. So those are the rules. Okay, so make sure you follow them when you are putting something in scientific notation. All right, and then C, they're saying 48.56743. They want us to round off this number to 1 significant figure. Okay, so 1 significant figure means I'm going to come there. Okay, so is this 8 greater than or equal to 5? Yes, so it's going to be 5. And then where those 8 there, I'm going to put 0. okay? And then 0.00000. But if we look at this number here, okay, since there's a decimal place here, it means all these trading zeros here are significant, okay? So it will mean that it will have more than one significant figure. So how do, how do we represent our answer? Our answer will just be 50 like that. So it will be 50, okay? It will be 50. So 50 will be our answer. If you want, you can put it in scientific notation to be 5.0 times 10 to the power 1. Okay, so those are the significant figures there. Let's look at the last one here on question 4. So the last one is, okay, so the last one is D. So on D, we have 2, 2, 4, 8, 5, 5. They're asking us to round this off to 3 significant figures. So we are going to come here. Okay, so we ask ourselves, is this 8 greater than or equal to 5? Yes, so we add the 1 to that number. So it's going to be 2, 2, 5. And then where there's 8, 5, and 5, we are going to put zeros like that. Okay, so this number here has only, okay, it has only 3 significant figures. If we want, we can write it in scientific form. So the decimal place is at the end there. If a decimal place is not shown in the number, it means it's at the end there. So we are moving it 1, 2, 3, 4, 5. So that would be 2.25 times 10. Okay, so we moved to the left. We moved to the left, right? So it means our power should be a positive. So that would be to the power 5 like that. Okay, so you can represent your answer in this form or that form. Still the same. Right, so any questions there? Okay, no questions. I'll proceed to question 5. Okay, so question 5, we are adding and multiplying, dividing, subtracting numbers with different significant figures. Okay, so there you just have to know 2 rules that we are going to be using. Okay, so when you are adding or subtracting 2 numbers that have a different number of significant figures, your answer, okay, should have the same, okay, the same number of decimal places as the least number, okay, as the least number there. So meaning that if I'm adding 2.1 to 1, if I add these 2, I'm going to get 3.1. So your answer, your final answer should have the same number of decimal places as the number with the least number of decimal places. So this one here has 1 decimal place, which is just this one. This one here has 0. So it means your final answer when you add these 2 should have what? 0 decimal places. So it means our final answer here will just be 3. Okay? So that's the rule when you are adding or when you are subtracting. Okay? And then when you are multiplying, okay, when you're multiplying or dividing, okay, then your final answer should have the same number of significant figures, okay, the same number of significant figures as the number that had the fewer significant figures. So here, when you're adding or subtracting, get it right, okay, when you're adding or subtracting, you are looking at the number of decimal places, okay. So your answer, your final answer should have the same number of decimal places as the number which had the least number of decimal places. But when you are multiplying or dividing, your answer should have the same number of significant figures, okay, as the number that had the least number of significant figures. So for example, if I have 2 there multiplied by 4.001. So this one here has only 1 significant figure, but this one here has 4 significant figures. So when you multiply these 2, your answer, your final answer should have the least number of significant figures. So it means your answer should have 1 significant figure. So if I multiply this, I'm going to get 8.002. 2. Okay, so you have to make now this number to only have one significant figure. So it means one significant figure to only be 8 like that. So that will be the final answer. Okay, so those are the rules that we follow whenever we are multiplying or dividing. And then adding or subtracting, we follow the number of what? Decimal places. So now let's solve these questions there. Okay, let's solve these questions. So there now we have, okay, we have A, we have 16.5 plus 8 plus 4.73. Okay, so you just use your calculator to add this. So this number here, okay, this one here has one decimal place. This one here has 0 decimal places. This one here has 2 decimal places. So it means your answer should have 0 decimal places. Okay, so you just punch this onto your calculator. What are you going to get? Okay, so when I punch this onto my calculator, I'm getting 29.23. But remember, our answer should have 0 decimal places. Okay, so it means our final answer will just be 29 there. That's all. Okay, so that's the rules that we follow when we are adding or subtracting. So let's look at B now. So B, we have 23.27 minus 12.058. Okay, so this is going to be equals to, so let's count the number of decimal places that we have here. We have 2 decimal places, and then there we have 3 decimal places. So it means our answer should have what? 2 decimal places. Okay, so just punch this on your calculator to get the answer there. So if I do 23k minus that, I'm getting 11.212. So this here has 3 significant figures. So we have to make sure that it has what? 2. So if it has 2, I said significant, I have to say decimal places. Okay, so we have to make sure that this number has 2 decimal places. So we just round off from here. We're just going to get 11.21 like that. Okay, so this answer now has 2 decimal places. So this is the correct answer there. So any questions there? Right, I hope you guys are understanding. Okay, because you've been quiet today. All right, let's look at C. So C, we have 38.91 multiplied by, and then in the brackets we have 6.81 minus 6.730. Okay, so whenever you have some numbers in brackets, just make sure that you start from what you have in the brackets. Remember your board mass from your grade 12. Okay, that's what you use here. So you start from the brackets and then you go out like that. So we have to deal with this. Okay, so if I deal with this, what am I going to find? So 6.81 minus 6.730. So this one here has 2 decimal places. And then this one here has 3 decimal places. Okay, so when I subtract this, my answer should have 2 decimal places. So just punch this on your calculator. What is it going to give me? Okay. Okay, so it's giving me 0.08. Okay, so we see that this answer has 2 decimal places. So that's what we want. So it means whatever is in the brackets here gives this result. So the next step now is to say 38.91 multiplied by 0.08. So now here we are multiplying. Okay, so we consider the significant numbers or the significant figures. So this one here has 4 significant figures, but this one here has what? 1 significant figure. So it means when we multiply this, the final answer should have what? 1 significant figure. So equals to, so just punch this on your calculator. So if I punch that on my calculator, I'm getting 3.1128. Okay, so this one here has 5 significant figure, but our answer should have only 1. So we're going to round off from there. So we're just going to have 3. So 3 there is the answer. Okay, to 1 significant figure. So any question there? Okay, let's look at D then. So on D, what do we have? We have division there. So D, we have 35 divided by 0.0622. So how many significant figures does this one have? It has 2 significant figures. This one here has 3 significant figures. So it means our answer should have what? 2 significant figures. So just get your calculator and then punch in that value. You're going to get 562, okay, 562.7037. So this is going to be equals to, okay, so it means we have to round off this number such that we have 2 significant figures. So we're going to round it off from here. So we're going to have 56 like that. Okay, so 56 will be our final answer. Only 2 significant figures like that. Okay, so any questions there, guys? Any questions there? Okay, no questions. Let's go to question 6, which is on unit conversions. So I remember the first class that we had in chemistry, I taught this. Okay, so you just have to know the metric system. Okay, what is the kilo? What does it represent? What is the nano? What does it represent? A milli, okay, a centi, just like that. Okay, and then for some of these questions here, we're just going to be using directly the conversion factors. So I also sent a video on that. So if you watched, I'm sure you have no problem here on converting these units. Okay, but if you didn't, then you have to follow what I'll be doing here. So question A, they're saying convert 5.897 kilograms to grams. Okay, so we said we just have to write this same number there, and then we multiply by the value of this prefix here. So we have a kilo here. Kilo is 10 to the power 3. Okay, and then we are going to divide by the prefix of where we are going. So this is just grams. Okay, it doesn't have any prefix here. So it means its value is just 10 to the power 0 like that. Okay, so this will just be 5.897 times it. And then this 10 to the power 3 is the same as 1000. This 10 to the power 0 is the same as 1. So just multiply this by 1000 on your calculator. We should get 580.97 grams. So this here will be your answer. All right, so any questions there? Okay, so now let's look at question B there. So we're using the same approach of the metric system. So B, we have 7.89 times 10 to the power minus 7 meters, and then we are converting this to what? Nanometers. So we just have to know the prefix for nano. And then this meter here doesn't have any prefix. So it means it's 10 to the power 0. So we are going to say this is equals to 7.89 times 10 to the power minus 7, okay, times, since it doesn't have any prefix, it will just be 10 to the power 0, and then divided by what you are converting to. Okay, so what is the prefix for nona? What is the prefix for nona? Nona is 10 to the power minus 9. Okay, so this is just going to be the same as 7.89 times, and then this to my 10 to the power something, let's put them together. So this is 10 to the power minus 7, 10 to the power 0. So this is the same as 10 to the power 7 plus 0. That will just give us 10 to the power minus 7 because we are multiplying here. And then here we are dividing, okay? So let me first of all write it just the way it is, and then I'll say 7.89 times 10. So since here we are dividing, it's going to be minus 7 minus the power that is down there, which is minus 9. So that's what we're going to have. So I'll come on top here to be 7.89 times 10 minus 7 plus 9. So that would be the same as 7.89 times 10. What is minus 7 plus 9? It will be 2. Okay, so 10 to the power 2 is the same as 100. So When we multiply this number by 100, we're just going to get 789. And these are what? Nanometers. So it's as simple as that. You should never struggle to convert these units. Never in your life. Okay. So if you didn't watch that video where I was explaining this, please go back to it. Okay. You can find it on my YouTube channel. Just search converting units by metric system to Tapo solutions. The video should come up. Okay. So that's how we can solve that one. Unless there are any questions, you can ask. All right, let's look at C. So C, we have 10.56 milliliters. We are converting it to what? To liters. Okay. So what does milli mean? Okay. So milli is 10 to the power minus 3. So this would be 10.56 times the milli is 10 to the power minus 3 and then divided by, this is just a liter, so it doesn't have any prefix there. So we divide by 10 to the power 0. So this is just going to be equals to, okay, this will just be 1. This will be 10.56 times, okay, 1 over 10 to the power 3, which is the same as 10.56 times 1 over 10 to the power 3 is 1000. So this is the same as 10.56 divided by what? 1000. So what are we going to get there? We're going to get 0.01056 liters. Okay, so these milliliters, converting them to liters are just this. If you want, you can just use the conversion factor. You can say 1 liter is equals to 1000 milliliters. And then you say, what about if I have 10.56 milliliters? How many liters am I going to have? Then you cross multiply. You're still going to find the same answer. Okay. All right. Let's look at the other questions there. So the other question there is similar to this one here. So I remember in that video when I was explaining about units, I said milliliters is the same as the cubic centimeters. So whenever you see milliliter, it's the same as this. Okay. So there we have 6.78 cubic centimeters. We want to convert it to liters. So milliliters and cubic centimeters, they are the same. Okay, so it means 1 liter is just going to be equals to 1000 cubic centimeters, and it's also equal to 1000 what? Milliliters. Okay, so here we can use some conversion factor. So we're going to say 1 liter is 1000 cubic, like that. Okay, what if I have 6.78 cubic centimeters? What will be my liters? Okay, so you cross multiply. It's going to be 1000x is equals to 1 times this is going to be 6.78. Divide 1000 on both sides. You're going to get your x to be. So just punch this part into your calculator. Going to get 0.00678 liters. So this one here is your final answer. All right, so any questions there, guys, before we do the last one? So the last one is on kilometers to meters. Okay, so there you can use the metric system. If you want, you can use the conversion factors. Okay, so let's use the conversion factors here, but if you want, you can use the metric system. So it will be 4.6 kilometers is equals to x meters. And then we know that 1000 meters is just equals to 1 kilometer. So cross multiply, we're going to have x is equals to 46 point, is that 45? Why did I write 40? Okay, 45.6. So this one here is 45 multiplied by a 1000 like that. So if I multiply that, I'm going to get 45600 meters. So this here is the distance in meters. All right, so any questions? Okay, we look at question 7 then. So question 7, they are saying write the following numbers in scientific notation. So we have 0.00076. So we have to make this number here greater than 1 but less than 10. So we're going to move this point Okay, from where it is here, we're going to move it to 1, 2, 3, 4. Okay, so that number there, the 7.6, is greater than 1 but less than 10. And then times 10 to the power. How many times have we moved? We've moved 1, 2, 3, 4. So we've moved 4 times to the right. So the power is going to be minus 4. Okay, so that is A. Let's look at B. So B, we have 123,000. So it means the decimal place is at the end there if you don't see it. So it means the decimal place is here. So we have to move it 1, 2, 3, 4, 5. Okay, we have to move it 5 times. So that would be 1.23 times 10 to the power 5. Since we moved to the left, so the power should be positive. Okay, and then C, what do we have? We have 8700. Okay, it's 700. 0 with a point that they are showing. They are clearly showing this point in that number. Okay, so maybe I forgot to mention. Okay, so when you are changing the numbers into scientific form, make sure that the number of significant figures that you had here is the same number of significant that you have in the number that you've put in scientific notation. So here we had 2, even here we had 2. Here we had 3, even here we have 3. But in this number here, okay, since it has a decimal point at the end there, they have clearly indicated it on the question there. It means it has how many significant figures, this number? 1, 2, 3, 4, 5. So it means our scientific notation form should contain 5 significant figures. So how are we going to do that? We are going to say this point, we move it 1, 2, 3, 4. So I've moved that point 4 times, so it will be 8.7. Okay, but to make this number have 5 significant figures, I'll add 3 zeros like that, and then times 10 to the power 4. So this number here, since these zeros come after the decimal place, it means they are significant. So we can count them as significant. So that number still has 5 significant figures, but it is what? In scientific notation. Okay, so let's look at the last one. So the last one is D. We have 0.00910. So how many significant figures do we have in this number? 3. Okay, the 9, 1, and this trading 0 because of this decimal point here. So let's move this point 1, 2, 3. Okay, so it's going to become 9.1, and then we're also going to add this 0 like that, and then times 10. How many times have we moved? 1, 2, 3, and we moved to the right. So it means the power there is just going to be a -3. Okay, so this here number, this first part here has 3 significant figures, just like the original number. All right, any questions there, guys? Okay, I'll move to question 8. Question 8, they're saying consider the following targets. So we have A, B, C. So they're saying comment on the results in terms of accuracy and precision of targets A, B, and C. Okay, so we see that from target A, okay, all these to my arrows, okay, or to my dots are going on the same spot there. Okay, they're just on the same spot. So it means those arrows are near, okay, to the target, near to target, and they are also near to each other. Okay, so if they are near to the target and they are near to each other, we are going to say the results from A are both accurate and precise. Okay, they're both accurate and precise. And then what about B? So this was A, and then B. So B, what we see is that the dots there are far from the target. So far from target, okay, but they are close or near each other. Okay, so what would be our comment there? on the accuracy and precision. Okay, since they are far from the target is here at the center. Since they are far from the target, we are going to say not accurate. Okay, but they are close to each other there, so we are going to say precise. Okay, so they are not accurate, but they are what? Precise. And then we can look at C, which is the last one there. So on C, we see that the tomatoes are just scattered. Okay, they are far away from the center or the target. They are also far away from each other. So far from target and then far from each other. Okay, so if you have such a scenario, then you are going to conclude that the results there are both not accurate, okay, and they are not precise. All right, so any questions there before we look at question 9? Okay, let's look at question 9. So question 9, they're saying a cooling mixture of dry ice and isopropyl alcohol has a temperature of minus 88 degrees Celsius. What is this temperature in kelvins? So to find the temperature in kelvins, you just add the temperature in degrees Celsius plus 273.15. So this temperature in degrees Celsius is minus 88 degrees Celsius plus 273.15. So this is going to be equals to what? Okay, so just add this on your calculator, giving me 185.15 kelvins. Okay, so this will be our temperature in kelvins. Very simple when you are converting the temperatures there. Okay, I think I also shared a video on this kelvins things. Okay, let's look at the last question today. So the last question there is, they're saying a fake engagement ring has a mass, okay, mass of 16.52 grams. And then they're saying a graduated cylinder initially contains water. Okay, so we can say V1 or volume 1, 10.72 milliliters of water. When the ring was submerged in the graduated cylinder, okay, when it was put in this water, the total volume increased to 14.24. So it means V2 is just 14.24 milliliters. Okay, someone is asking a question. I can get some background. All right, and then the question here, they're saying determine the density, okay, of the ring in grams per milliliters to 3 significant figures. Okay, so we know that the density is equals to what? Mass over volume. So we have the mass of the ring, we just need its volume. So how are we going to find its volume? So we're going to say volume of the ring is just going to be equals to, okay, the volume of the ring is just going to be equals to, okay, V2 minus V1. So V2 is 14.24 minus 10.72. So if we subtract there, what are we going to get? Okay, so my calculator is saying 3.52 milliliters. So this is the volume of the ring, and then this is the mass. So now we can actually find the density. So density will just be equals to the mass, 16.52, okay, 16.52 grams, divided by the volume, which is 3.52 milliliters. Okay, so what are we going to find there? This is going to be equals to, so get your calculator and then punch in that value. What are we going to get? Okay. Okay, so let me do that. So we have 16.52 divided by 3.52. So I'm going to get this number. All right, all of it. So 4.6931818182. Okay, so they said 3 significant figures. So we round this off to 3 significant figures. It's just going to be what? 4.69. grams per milliliter. So this is the final answer there. And we are done with your assignment. Okay, so any questions? Okay, so people were writing in the comment section. So I'm not able to see the comment section where I'm teaching here. So what you should be doing is just unmute yourself and then you ask the question. Okay, so if you type in the comment section there, I won't see it. Okay, I can only see it at the end. Okay, can only see it at the end. All right, so those who are asking questions, please repeat on question 9. Okay, so question 9, you just use the formula for converting the temperature in kelvins to the temperature in degrees. Okay, so I'll send another video there so that you can watch the explanation there. But I also send this video, I also send written solutions for these same questions here so that you can understand. All right, so any other question?
Question 8.
Okay. So question 8, what did we have on question 8? Here, what's your question
Target.
there?
I didn't understand about how you are finding these targets.
Okay, so it's like this. I don't know if you know that game for darts. So if you have something stuck on the wall and then it has a target there where you have to hit. Okay, it has a target. So you throw your tuma darts there. Okay, you throw your tuma darts onto that target. So here on the first one, all the tuma darts are going right at the center. Okay, they're just going there. They're just hitting there. No wonder you can see this dark thing here. Those are tuma darts that are being thrown, okay, at this target. Okay. So if all your tuma darts are just going at the same point like that, okay, we say that they are accurate because they are closer, okay, or they are at the same place where the target is, so they are accurate. And then they are also precise since all these tuma darts are just at the same point like that, okay. And then when you look at the scenario that you have on B, it means when they were shooting these targets, okay, I mean these tuma darts, the target is there, okay, this is the target, but when they are shooting, all the tuma darts are going at that point like that. They're going at that point like that, okay. So these tuma darts are far away from the what? The target. So they are not accurate because they are far away from this target, but they are closer to each other. So we are going to say they are what? Precise. And then in the third scenario here on C, we have this scenario. So this is the target here. And then you start throwing those tuma darts. Okay. You start throwing those tuma darts. Some of it can go there, some of it can be there, some of it can be there, some of it can be there. So what we see here is that, first of all, these tuma darts are far away from the target in blue there, okay? And they are also far away from each other. So we are going to say they're not accurate, they're not precise. Okay, so the one who was asking there, have you gotten it? Hello, the one who was asking the question. Okay, I hope you have. So thank you so much for attending this class where we're solving this assignment. So our free classes continue until the end of February, okay? And then afterwards, if you would like to register with us and continue learning with us, you can register. So the tuitions will be 100 kwacha per course per month. All right, so have a blessed night and make sure you submit correct answers for your assignment.
Thank you very much, sir. We appreciate it.